Good afternoon. I am alone right now in the chat. Let's see. I'm going to wait for people to show up, but I'm right here. I'm going to look at questions that have been posed through email. Students have sent me questions, and as I've done in the past, I will answer them here, and then I'll put the links of the timestamps for when I to locate the position in the video where I discuss particular questions from which exams. I will note all those things. Hi, Mylene. We'll wait a little bit for other people. Did you send me any questions, Mylene? I have questions from Madeline, Caroline, Isadora. Ah, you did send me a question, Mylene. I got it here. Okay, let's see if I can. Can you send me the question, the precise question, or? Well, let's see. I'll take screenshots. I have to set up my computer. You guys sent these at the last minute. Oh my goodness. I appreciate the questions, don't get me wrong. It's just I have to set everything up and it takes time. I don't know if this is going to show. Okay, Maylin asked me a question. Let me start with that. Here. Mylin. I'm going to just put it into the folder that I'm using. I'll go get it. There it is. Hi, everybody. Okay, so I'm going to go one at a time through the questions. Oh, this didn't look so okay. I should have shrank that. Okay, the percent. So Maylin sent me this question. I'd like to understand the percent of the observations that are suspected outliers according to the 1.5 times IQ raw rule is the same as a normal distribution. Okay, so if a distribution is normal, the percentage of outliers, this here. So if a distribution is normal, the percentage of outliers is 0.3%, right? It's normal, it's symmetric, and we say out here and out here, this is not the greatest drawing, are 3% or 1.5%, sorry, 0.15% on each side. Oh, you can't see that. All right, so it's like this. Now, since you're using, so this is where you know actually the shape of the distribution, that it's normal. It's always, for a normal distribution, it's 0.3. When you use the IQR rule, usually you're using that rule on a, to check if there's an outlier, and you use that for skewed data I taught you. But I do ask some questions where I have asked you to apply the IQR rule when the data is symmetric, just to see, it's kind of interesting that there are different rules for different shapes of distribution. So what would it be? What would be the case? Well, it's important to note that when you do this, the number of outliers, or the percentage of outliers, is going to vary from distribution well, let's see, wait, I don't know, IQR. Is it set? What is this 0.7%? Okay, so if we do the IQR rule for the normal distribution, that's the question I guess I asked. So if you have a normal distribution, not just a symmetric distribution, what should the what should the test tell you? What percentage of observations? So you need to go through all the steps. It's just many, there's many steps. You want me to solve this? So if you have a normal distribution, imagine that this is normal. But we have suspected outliers. Want to know, it's in terms of normal, using the symmetry. Outliers for symmetric distribution are outside this range, right? That's what we discussed. But if you apply the IQR rule, what will you get? That's the question. So 1.5 times IQR as the inclusion what will you get? Over here, you'll find that 3.5% outlier, 0.3% outliers. But if you do this, the question is, what percentage are outliers? So so you need to know the IQR. What's IQR? IQR, where would be Q1 and Q2? Sorry, Q3, because we know Q2. Q2 is the middle of a normal distribution. So Q1 is where 0.2500 of the observations are. So 0.25 or 25% of the observations are there to the left. So what would this value be? And then for the 75th, and we're doing this on the standard normal, okay? It can only be done on the standard normal, or I have to be more detailed with my information. So using the standard normal as our template, remember all the distributions that are normal are spread out just like the standard normal, where we interpret each value here, the z-score, as the standard deviations from the mean. Okay, so so this is going to be 0.7500 to the left, right? Because that's the third quarter. So this is the first quarter, the second quarter. We know that that's going to be 0, right? It's in the middle for the standard normal. So what is Q1? So where is the position? What is the z-score for 25% below? Once we have that, because of the symmetry of the z distribution, we'll know whatever this is going to be a negative. Q3 will be the positive version of that. All right? So when you look up 0.25, what do you find? In the tables? What do you find in the tables when you look up? So this is going backwards. It's going to be on the negative table and look for 0.2500 inside the table. So I'm going to give you the answer, 0.2500. The closest thing is where it's 0.2514 corresponds to negative 0.67. So this would be negative 0.67. Are you following me? So I need to find the z-score, where the 25th percentile, in other words. I need to find the z-score with 25% of the observations to the left. If I use the table, this is the closest I can get to 25%, and that corresponds to negative 0.67. Because of symmetry, this one is positive 0.67. And so now what we want to do is take the IQR. So the IQR is going to be Q3 minus Q1, right? But that's just 0.67 minus negative 0.67, which ends up being plus 0.67. So, you know, I want this range here. That's what I'm looking for. So it's just it's 0.67 that way on the right, and it's 0.67 on the left. So this is going to be 0.67 times 2. Do you get that? And 0.67 times 2, just in case I lost you, I'll write it here, because this is going to be negative 0.67, positive 0.67 minus negative 0.67. Okay, you can think of it like that. So when you minus a negative, you're adding 0.67 to itself. Okay, again, it's going 0.67 this way and then 0.67 that way. So there's two of those. So the answer for the IQR is really 0.67 times 2. Which is 1.34. So then you have to take 1.5 times that, and you want to do it in both directions, okay? Because it's symmetric, if you have a long tail on one side, you're going to have a long tail on the other side. So you have to check both sides. If it was skewed, you would only have to check one side. So I hope I haven't lost you yet. So what we got to do now is we have to do 1.5 times 1.34, which is equal to is equal to 2.01. So you want to go 2.01 this way from Q1, and you want to go 2.01 this way from Q3. And then, so there's many steps. Just keep sight of your goal, what your goal is. Your goal is to find out how many outliers there are. What's the percentage of outliers? And we're repeating the same, we're repeating a lot of the same processes. Now I'm going to go and I'm going to take, I'm going to go over, I'm going to minus 2.01 from Q1, but I'm going to add 2.01 on this side. So what am I going to have? I need to go all the way from negative 0. Negative 0.67 minus 2.01 that way, and on this side I'm going to do the same thing. And once you get one side, you have the other with the symmetric distribution. You're going to add 2.01 on this side. So that's going to be negative 2.68 on that side and positive 2.68. And finally, the final step is to find out in a standard normal distribution, X8, and then you will know how many are to the right of positive 2.68. And with that, you'll know the outliers. So when you look up 2.68, negative the answer is 0.0037 on this side. And of course, it's also going to be 0.0037 because of symmetry on that side. But to use the table, I always take the left side. So I'll do that one. Oops. I'll calculate that one and then attribute it over on this side. So that's why when you multiply that by 2, you get the answer. The total total outliers for a symmetric distribution, sorry, not symmetric, a normal, standard normal distribution, the total outliers would be 0.0074 or 0.7%, and that's where the number comes from. Okay? Isn't that amazing? It took forever. The first time it takes forever, and then you get the hang of it. And there were questions like that in the quizzes online. So that's the answer to that. Yeah, I know. But did you understand, Maylin? She says, wow. You review that, okay? Review those steps. That's really good practice. Concepts that you learn for the normal distribution, which is symmetric, and that for skewed distributions. And yes, we don't have to do this for, we don't have to use this approach if we know that distribution is normal. And in fact, if you did too many outliers relative, if you call it a normal distribution and then because it's symmetric, you use the other test, x plus or minus 3s, what did I just do? Plus or minus 3s. For this situation, you're going to have 0.3% outliers. But if you did it this way, that we just did, using the IQR rule, you have many outliers. So outliers aren't so special, right? If we do it this way. We use this approach for the normal distribution to reflect that this is a rare occurrence. This number is smaller than that one. Okay? All right. So I'm going to save that. Anyone who didn't get it, if it was over your head, just review the video later. I'll provide the timestamps. So this is an example of so yeah, it's not straightforward. Now that you know, you just don't forget that, okay? So if you use the IQR rule and a standard normal, 0.7% are outliers, 0.7% of observations. You can remember that. It'll help you with multiple choice questions. But if you had to prove it, you'd have to take all those, take those steps. Okay. Who's next in the questions? Let me go back to my emails. Okay, Caroline sent me something. I'm going to put it into my files. I think I already did. No, she has the old one there. Okay, so I have to put it in here. Okay, it should show up. taking a little while to load. I put it in the wrong place. Okay, here it goes. I should come over. There we go. Mm-hmm. Whoa. Should I give you guys some time to look at this problem? Okay, 3 goalies have played for the Bulldogs soccer team in their 30 games this season. The following side-by-side box plots and statistics summarize the number of goals given up by the goalies in each of the games they played. There's 3 goalies. You have the total number of games, and you have the side-by-side box plots. I have the I have the means here for each of the goalies, but I want the overall mean. This is very similar. We did a problem like this before. What you want to do is convert the mean into the total. The total goals for Brandon, the total goals for Daniel, the total goals for Jason, and then add them together and divide by how many games total. All right, so what you're going to do is you're going to take this column, which is the number of games, and this column, that's the mean, and remembering that the mean, oh my goodness. The sample mean is xi sum divided by n. So I can find the total, which is just the top here, by multiplying x bar by the n. So this should seem familiar. We did this before. All right, so what you want to do is multiply this times this, and then this for Daniel times that for Daniel, and this by the number of games for Jason times the mean for Jason. Add them all together to get the grand total. Okay, so do that for me, get the grand total. And then we're going to divide it by 60 games. And that should be your answer, okay? Give that a shot. Make your calculations in columns. It's so much easier to see. Okay, and you can do the similar thing in Excel with one column and another column, then equals times the multiply the columns together, the formula. So I'm going to do that on Excel. So 30, 15, 15 in one column, and then 4.3, 5.6, and 4 in the next column, and then I multiply. And I sum. And I get 273. So I have 129, 84, and 60. And the sum is 273. So then I take that and I divide that by 60, and what do I get? I get 4.55. This is my option. This is the best answer. Very good. Okay. So that was Caroline's question. So maybe you thought you had to use the graph. Well, you had a lot of information here. You had the graphs, and you also had the statistics. So pick the stuff that you need, and this is all you needed to do. Extract that information and use this trick that we worked with the other day. Okay, who's next? Just going through the problems, the emails I got. Okay, my wait, there's Isadora asked me something. No, she just said thank you. You guys are just saying thank you, so that's not questions, but thank you. I'm gonna answer now questions from Marilyn. I think I took a picture of this one. I'm just getting the problem. I'm mounting it into the Dropbox folder that I have. And I'm just saving them in case. You never know, I might have to use them again or to go back and explain again. Okay, so let's see. What did Marilyn have to say? So I was practicing the midterms we're going to discuss today. I had some questions in the 26. Why exercise 21 can't be D? Which is A and B? Okay, so you gave me a list of things to do. All right. So, wait, I gotta go back. So that's for question October 26th. Okay, let's get October 26th. Okay, so you're telling me that the answer so for 21 the answer is B, and you're wondering why it can't be D. Okay. A textbook committee in the Department of Statistics plans to conduct a survey of first-year students who are taking Stat 1000 about the importance of a textbook in learning the course material. From the enrollment list of 2,000 students registered in the course, the committee chose a simple random sample of 200 students and emailed them a questionnaire. So where's this list from? Students that are registered. And what's the question? The importance of a textbook. Importance of a textbook. Okay, which of the following types of bias associated with sampling procedure? Okay. The issue of voluntary response versus so you think you're saying couldn't it be A and B? Why just B? Why is B the answer? So B is the answer. Okay, so everyone was mailed the survey, correct? And the problem is going to be, from the perspective of the research, that some people are not going to fill the survey out. I see your confusion that aren't they dependent on voluntary response to get an answer? Usually because they can voluntary response, you put it out there, and sampling procedure. I gotta think about that. Okay. Okay, the issue around voluntary response is that people who are responding for a okay, so maybe you can think of it like this. This is like a response bias, that the people who are responding might have a particular bias and desire to respond. So we usually use the terminology voluntary response being a problem when we're talking about like a controversial subject and people opting in for the study. But with non-response, these are people who are just not responding. I see what you're saying. that it's confusing, why not? I don't think I'm giving you a very good answer. Let me think about that some more, how I will frame that for you. Because definitely, yeah, people aren't forced to do a survey, so they are responding. I guess the issue is that this was a random sample. I think that's the difference here, because you're told students registered in the course, a simple random sample was selected. You see, voluntary response doesn't have a structure. Usually when voluntary response is done, that the idea of voluntary response is they just put a question out there and people, not randomly, but we say haphazardly, opt in. Haphazard is the opposite of random. When we say the word random in statistic, we're talking about we're assuring, we're doing our best to ensure that there's no bias in people selecting themselves into the sample, or there's no bias in excluding certain people. Okay? Voluntary response is the term that's used when we don't have a structure and we just ask people, we just put it out there. Like voluntary response would be if they put it on, and they just sent an email to all the stats students. Not a simple random sample. Okay, so that would be the key thing here. There's a structure. It's a simple random sample, and then it has non-response bias. All right? How's that? How's that for an explanation? And yes, we will assume that all students had emails. Yeah. Sorry, I didn't read your comment, Juan Carlos, until I looked up. There's 17 of you. This is a high point. 17 of you watching. Okay, so the answer there was that to clarify that voluntary response is where there's no structure, there's no sample, it's just haphazard. You just let people opt in to answer questions of a survey. Okay, but there was an implied structure, which is great. That's going to control for most bias, but it can't control, because you can't force people to fill out the survey. You're going to suffer from non-response bias. Okay, good. Let's see, what else? I didn't save it. Also, I just couldn't get the right answer to 31, 35, and 39. Okay, very good. Thank you for the feedback. I really appreciate it. So I'll focus on those problems. 31, 35, and 39. Okay. I'm going to go back. Okay, so back to 26. So 31. Is there normal distribution problems? I imagine. Yes. Okay, no problem. Doing some more of these. Is this it? So this is exam. As I explained before, I'll put the timestamps in so you can find everything and follow along. But this is the October. We're still in the October 26th exam. All right. X follows a uniform distribution. Aha. So it's interspersed in the notes what a uniform distribution is. It's basically a box. Okay, so let's do it here. It's very easy. Once I do it, you're gonna get it. I did one with this, yeah, last week, I guess, with the box. But we get to draw the box even here. So there's a uniform distribution from the interval 37 to 84. And the thing that we're testing here is your understanding of densities. So from 37 to 84, the probability of being in a range that's low, like between here and here. Now, because it's a continuous distribution, you can only talk about ranges. Remember, we discussed that when I introduced the density curve and the normal distribution at the beginning of Unit 2 NOR. So the probability of being in this range here is equal to the probability of being a high value. So probably the chance of being a low value is just as likely as being a high value in that range. That's uniform. Okay, okay, so now between 48.2, which is, I'm going to do my best to mark it, so 48, let me check something. Okay, so the middle would be, about here. To get the middle, the midpoint, you would add this to this and divide by 2. So that's like about 60. I want to be at 48. So 48, I'll mark it with a blue. So let's say 48 was like here. 48.2 and B, whatever B is, this area here, you're told is that much. Okay? And what you are interested in is what's B. So this is an exercise to develop your skills in understanding or comprehending density curves. So this doesn't look very good. So that extreme, I'll just put it lower here. So this is 48.2, and this is B, and you want to find out what B is. So it's just a box. To know the area of a box, you can use height times width is equal to the area. We know the total area of the red box is 1. But every other box, to calculate the area of any other rectangle, you would apply the same concept, that is height times width. Oh, why is that happening? Oh, we have a glitch. I don't know why that's happening. Let me save it. Maybe it'll... Maybe it stopped sending the signal? No? I'm not sure why it's frozen like that. How annoying. Sorry, guys. One of you guys can phone me. Oh, maybe I don't even have my phone. Phone me when things aren't working, because I'm focused on what I'm writing and I haven't mastered looking at two things at the same time. So just phone me to get my attention. Oh, Eric wrote me. So it's been frozen for 2 minutes. Very good. I don't know why it's doing that. Okay, let me reset or something in the OBS. Start recording. Start streaming. No. Let me. I don't know why it's frozen on that screen. I'm going to reboot. See all the editing that goes into making videos. Jeez. I know about it. And okay, something moved, right? Are things moving? I don't know why it's jumping like that. I don't know what it's doing. Technical breakdown. See if I... What does that give you? Did it do anything? Oh my goodness, it just won't change pages. Oh, some things moved around. And back to this, the first page. So let's see if I can just, I'll take a picture. See if I can just use that picture. 31. What possibly happened? Work. I don't know, guys. We're having another surprise. Let me cut the mirroring. I had to reboot everything last time. Now do you see it? I think it's going to show up now. Yeah, I keep on doing that. I keep on trying to change the source, but I worked. Oh my goodness, I'll never know. Okay, so let's see. What did I do here? I'll go back. Can I go back? I don't think I can go back. I'll erase all this. Oh, I erased everything. Okay, so this is what we're looking at. And what I've done is I've demonstrated, this is the uniform distribution. So uniform distribution is really a rectangle. Okay, it demonstrates that all the possible outcomes have equal likelihood is what it's saying. And the way I see that, remember, because it's continuous, I can be at any value here, fractions and all that. So my analysis should only be by ranges. So this outcome that's a lower outcome is just as likely as this high outcome, whatever the variable is. I don't explain the details of what the variable is, but if students are just as likely to get 37%, let's say, on their test as they are 84%, like somewhere around, like, so let's say people are just as likely to fail as they are to get, a high grade in between here. So if you take equal ranges, they have equal probabilities. So the lowest 10 scores has equal chance as the highest 10 scores. All right, so the mechanics, the geometry is that we know that the density curve should have an area of 1. So the area of the density curve, which is just a box, has to be 1. And how's that calculated? We know that that is equals height times width. Okay? And usually I put things in alphabetical order, but sometimes I fall out of it and I might put weight times width times height, put it in the other order. But anyway, you get the point. It's these things multiplied together. The way I multiply them won't change the answer. But the convention is to put letters, variables, or values in that are letters, represented as letters, in alphabetical order. All right, back to the problem. So this is about this uniform distribution. We know the area has to be 1. So we can figure out, before we even continue and make a mess, let's figure out what the height has to be now, because I haven't told you what the height is, right? But you can solve for that. What is the height? To find the height, you're going to need the height times the width, times the width to equal 1. So this we know, height we don't know, but width we know. Width is always solved as upper versus a minus lower. So the upper value, the higher value is 84, minus the lower value is 37. Okay, so that will be the width of the interval. So that's 47. So this is 47, and so height must be 1 over 47, right? Because I want to isolate h, you can think of it like that. But also, what number would I multiply 47 by to get 1? Well, it has to be the inverse. Okay? That will make it 1. So h has to be 1 over 47. So I know h now. Can't erase that. So h is 47. So this is 47 is the height here. I can't even see that option. So h is 47. Now, between 48.2 and B is 28.72%. 28%, 28.72%. Oh my goodness. So then 48 is like almost here, and B is wherever, and I want to find out what B is. Okay, now this is 48.2 right here. What is B? This is going to be 0.28. All my lights are on. All my lights are on. How about everybody else? Can you hear me? Why would that happen? Audio. Is that better? You hear me again? Weird. Okay. So where did I leave off? Well, you were watching, I guess. So this is so this is 28.72, and I know this is 48.2. I'm going to redraw it. I'm going to redraw it. So this is just to make more room for myself. So let's say this is the same thing. So this is 37. This is 48.2. I like to put them on a line. And then B is here. Okay? And this is not to scale. Don't be looking for a scale drawing for me at this point. Not with all the challenges. Okay, so between here and here is 0.2872. And I want to know what B is. So it's all 1. The whole thing is 1. So all I have to do is figure out either, well, since I don't know B, it's going to be hard to figure out the box here, right? Because I need the width and the height. The height I have, I already figured that out. That's 1 over 47. So let's do it here. So this would be the width. So we just keep on calculating again, width times height, or height times width, using the same principle for whatever we need. It's just a bunch of rectangles. So this width here and this height here would give us this area here. And then with that, we can make an equation with b in it. Again, these are very challenging problems. I'm not going to make them all so challenging on the test, but you shouldn't give up. You should identify what you're good at, what's going to take you a long time, and what's going to be easy. You only have to answer, remember, 30 of the 40 problems. Okay, so with the width here, I have to move this up again. Uh-oh. So these are divided now. There we go. Okay, so that's my drawing. Okay, so let me give you a few minutes. You guys can try and solve it. Let me give you 2 minutes. Okay, 1 more minute to solve. Anybody get it? Or you're just waiting for me? You went and had a break? You made a coffee or something? Let's see. Any answers? Not yet? So I haven't even looked at the alternatives. I'm just trying to solve this. So let's see. There might be a more strategic way, but okay, so height times width. So area equals height times width. The height is 1 over 47. And the width is, remember, upper minus lower. So 48.2 minus 37. So this is 11.2. And that will give you the area of this. Are you with me? So that 11.2 divided by 47 is equal, hope I didn't lose you, is equal to 0.2383. So this is 0.2383. 0.2383, and together that is the area between here and here. So the area of this so what is that going to be? What's 2383? So 0.2383 plus 0.2874 is what? If you just hang in there, you don't have to be a genius, you just have to be perseverant. You really don't have to be. I'm not a genius. I'm just perseverant. 5257. So that's the area in the red. Okay, so now that area is equal to the height times width here. So what is that? That's going to be 1/47 times b minus 37. So that's what you want to solve, I believe. Okay, so find out what that time. So again, you can work this with Excel just to get the calculations. It's like the fastest way, and it lays everything out. So I'm getting 24.7078 equals b minus 37. So b must be 61. Unless I made a mistake and somebody knows what I did wrong. That's what I get. Is that one of the options? Is that one of the options is the question. How do you get 11.2? 11.2 comes from the width. How do we get the width? It's always the same formula. The width is equal to the upper minus the lower. So for this, here, that's how I found it. The answer D, 61.71 or something like that, is B option. Okay, ask me more questions. I'm going to stay on. If anybody has a class, you can check back in for the answer. Yes, I know it's kind of long, but perseverance, show me your work. If you ever make a mistake, out of 2 points, I can give you 1.5 or 1 point if you just show me your work. Lots of work to show me in these calculations. $61.7, very good. Shall I continue? She also asked me to solve 35 and 39. So I'm going to continue. If you guys have to go, get going. The exam is going to look like these exams, Carolina. The exam is going to look like these exams. It's going to be laid out with 40 problems, and you pick 30. I'm going to ask you to give you an opportunity to upload your work. I'm going to post the exam, and it's going to open at 6 p.m. and you will have until I could give you 3 hours. It's just I don't want you spending too much time on it either. I was just going to give you 6 till 8. So the instructions will be on the exam. If you do these exams, you'll know how it works. So basically you're going to go in, the exam's going to be there, you're going to open it, and you're going to answer the questions. And you can see, I have to try and prevent cheating, so it has to be that I put the questions and you have to choose the options. And you're going to have to choose 30 out of 40. So I'm going to have to let it so that you can go back and forth and change your choices and keep track. So when I send you the exam, I'll send it with, I'll just send the questions. You guys can take screenshots probably and print it if you have to. But essentially you have to choose options, just like the quizzes. The questions are going to go up, you choose the options, and then you should only submit 30, not 40. If you submit more than 30, I'm just going to mark the first 30. It's 2 hours. You guys want 3 hours. Yeah, Isadora, don't worry. Just keep studying. You keep practicing. You're going to be fine. Just pick the easy ones. They're not all hard. You guys are asking me all the hard questions. They're not all going to be hard questions. Okay? Yeah, you're going to have to be able to go back and forth. I'm going to have to allow that. No cheating. How many times I have to say that? No cheating. But you should be working on your own. Also, don't trust anybody's answer because then you're really going to kick yourself if they got the wrong answer. And don't give anyone your answers because you can't be sure you got it right either. So you're going to have to just focus. I'll give you 3 hours if you promise me not to cheat. So 6 till 9. And at the end, you'll have 10 minutes. Well, I'll give you 15 minutes to orient yourself, upload your work, the pages. Either you can take a picture if you have troubles, like you don't have a scanner or something. You can just take pictures and send them to me, and I can go through your pages and see if I can find part marks for you and some problems that might deserve it. Okay? Okay, 3 hours. So should I do 2 more problems? 35 and 30. So this is, just to summarize here, B was 61.7, and that was option D, apparently. Carolina, it's a balanced test. So this is, since you get to choose, focus on the questions where you're stronger, okay? So make sure you're stronger in something than the other things. Just know your weaknesses and know your strengths. That's what's really important, to know what you know and what you don't know. Okay? So yeah, you should be able to go front and back. You will be able to go front and back. All right, let me see about getting question 35. I think we did 35. Didn't we do 35? Oh no, we did 34, sorry. Spruce trees, okay. Spruce trees. No. All right, let's look at 35. Diameter of spruce trees in a forest are known to follow normal distribution with a mean of 31.3. Suppose that 33% of the spruce trees have a diameter above 35.7. What is the standard deviation of the diameter of spruce trees in the forest? So this is a backward problem in that I give you the probability and you are supposed to give me the Z score and then the X score. So we're going back from probabilities to the value. I have the value. This is the twist, okay? So this is a backward problem with a twist. I'm going to find not the Z score and then the value of the variable or the percentile. That's not what I'm looking for. I'm going to be looking for the standard deviation. Now we did problems like this already, but I can do it again. It's very repetitive. I mean, you just have to keep doing these problems till you get it. Because they're just the same. They're really just the same. And once you get it, I hope you don't get bored. Keep in mind, remember that the solutions to all the homework, I have a package there under NOR where all the solutions are worked out for the NOR problems. Alright, so here we have a normal distribution. This is a backward problem. We know it's a backward problem because I've been giving the percentage. So what I do is a two-step problem where step one, I draw the Z drawing. So the Z drawing says, let's draw this. 33% of spruce trees have a diameter above, so 33 are above, so this is 0.3300, and that's above 35.7. Okay, so that's this area here. Well, what I want to find out is a standard deviation. Usually I put a Z here, right? For the backward problem, I usually put the Z here. Oh, sorry, this is not the Z. Sorry. Let me fix that. Let me do that one more time. Okay, edit. So this is 33. This is what we want to find. Z first. That's step one. And then I'm going to put the drawing. So when you do these problems, always draw the Z. The only time you draw the graph for the normal distribution is when I give you a problem that has to do with the 68, 95, 99.7 rule. That's the only time that you actually draw the X, like the normal distribution for the particular distribution we're talking about. But here you are working with Z first. Now, if you're to look this number up in your table, you should be getting a negative value because it's not this one that you're getting. You're getting the reflection on the other side. Remember, because the table only gives areas to the left, and this is asking for the area to life. But because it's symmetric, I can still use that information. So remembering that if you get this, this is just negative Z. It's just the negative version. So if you look at 0.33, what is the Z? So you go inside the table to find 0.33. The closest value you find is, oh, it's perfect, negative 0.44. So this is going to be negative 0.44. So then this one must be positive 0.44. Okay, so let me put this up. These layers, I have to get used to this. Okay, so because it's negative 0.44, I know that symmetrically what's here on this side is the same on that side. So I know that the answer, my z, is equal to positive 0.44. Am I finished? No, because what I really want is to transform this. This is just telling me how many standard deviations I'm away. So I'm 0.44 standard, so like a little less than half a standard deviation above the mean. So now we're going to transform that to the terms of the variable itself. So we say x equals z standard deviations from the mean. You see, when I say it, and I spell it out, I spell out the formula. So here I put in the x that they gave me. So x corresponds, the x they gave me corresponds to being the number that it is. Oh, not again. So the number they gave me, 35.7. 35.7 is 0.44 standard deviations above the mean. The mean is 31.3. Okay, so I'm going to put all those numbers in. Equals 0.44. Sigma is what I want, and this is 31.3. So I'm using this relationship where x is the value for whatever normal distribution. In this case, it's all about spruce trees. The diameter of spruce trees, right? So this is about the diameter of spruce trees, and 3.57 is equivalent to 0.44 standard deviations above the mean. So what should the standard deviation be? Solve this for the standard deviation. Solve this for the standard deviation, and that will be your answer. Okay, so this is a backward problem. Rather than looking for x, what you're looking for is sigma. But you can do that. It's still it's exploiting the same relationship between them. So 3.57 or 35.7. I have to go back. I wrote it wrong. Not like I haven't done that before. It is 35.7. I put the decimal in the wrong place. Okay. 35.7. So 35.7 minus 31.3 divided by 0.44. I don't know why that's showing. It's going to be equal to your sigma. Emergency alert. So sigma is whatever. What is it? standard deviation. Again, I apologize that my stylus isn't so great. I'm really not in a position. I can't buy one because they're not, I can't go to a store to buy it. And online, it doesn't look like they're so great. And they're not going to come until next month, so there's no point. Okay, I get a sigma of, what do you get? Nice. When the numbers turn out round, that's always hopeful that you did something right. I mean, not all the answers have whole numbers as the answer, but if you get a whole number, you probably did it right. Very good, Isadora. Very good. Okay, so review that. And you'll see, you know, there's lots of problems that are very similar to that one. Okay, let's go to 39. Slow, right? The slowest 7% of runners. Slow. So now this is a little bit tricky because slow does what? When they're slow, their times are high, right? But high, right? High is not a good thing. But in this case, the slowest have the slowest 7% of runners. So I give you a percentage, and I want you to find the corresponding score. Okay, so I want the variable where I give you the percentage. Draw the picture. This is also a backward problem, and it's straightforward. There's no twist here. So, is there more information up there? Oh, okay, they're all the same problem. So I have to use this information. Let's see. 39, okay. Times for so this is for the 100 meter, so it's the first one. Times for the 100 meter race follow a normal distribution with a mean of 11.74 and a standard deviation. So I'm going to write it down here as the mean. And a standard deviation of 0.43. Okay. Okay. All right, so the slowest are going to have high times. The better ones have low times, right? That's important just for the drawing. So slowest are going to be up here with the high times. High is not good. So 7% high will be up here, and I write 0.0700. I always use 4 to remind myself to go inside the table. Okay. Use 4 decimals. So the trick here, there's no trick, it's the same thing as before. So this is 2 steps. Step 1, is just to work with the standard deviations from the mean and then transform that into the variable that we're interested in. So how many standard deviations from the mean should you be to have 7% above you? So this is the position of the beginning of the 7% lowest group. So when you look that up in the tables, you're looking for 0.0700. And the closest one is negative 1.48. So when so 0.0694 corresponds to Z being negative 1.48. Okay, so this corresponds so if you look this up inside the table, you're going to get a negative, which is not this, right? Because this is a positive. But we know that the table is only giving us the left side, so it's actually giving us the value over here. So I need to know to use the negative of that. So the answer, so I'm going to put a negative here, so that basically I picked that up out of the table, but I have to make that a positive now. So Z must be positive 1.48. So Z is positive 1.48. And now the second step, X is equal to Z, or Z standard deviations from the mean. So X we can find as Z is 1.48, sigma is 0.43, and mu is 11.74. And putting all that together will give you X. So that would be in the drawing here. This is the Z drawing, but really what we want to report is not about how many standard deviations were from the mean. We want to know the value in terms of the variable X. So that will put it at whatever that adds to. $12.37. What do I have 12? What did I do wrong? Hmm? 1.48, 0.43, 11.74. Oh, I'm looking at the wrong options, that's why. Okay. Yes, 12.38. It should be D. Okay, you guys. Very good. Well, if you draw it, you won't be confused. Don't do it as an automatic change from negative to positive. Draw it and you'll see, because when you go in the table, you jump into the table and you see that you got a negative, you should not put a negative here, right? You have to remember, oh yeah, I got the value from the other side, because that's all the table gives you. It gives you this side. So the one you want though is over here, so that's why you have to take the positive version, all right? So don't be so distraught. Just draw the picture, don't jump steps, okay? Definitely you're going to get the wrong answer, and that's the trick. You're going to get the wrong answer if you're not careful. It intends to test that. Did I do everything that you asked me for? So I did everything you asked me for. The test is tomorrow. Throughout the day, if you guys send me problems, if you're really troubled with a problem, just let me know and we can get together, or I can do a video and let you know if it's up there. I can just pop in and make videos for you. Okay, because everything's set up to go. So realize there's a pattern, and the more problems that you do, you'll start seeing the pattern. All right? And do not despair. It's not a waste of your time. If you're spending too much time on a problem, and you're pretty much, and you're kind of guessing or you're floating, you probably did something wrong. Okay? You shouldn't be spending too much time on any one problem. If you're spending too much time, just go to the next one. Find the easy ones. You just got to find like 20 easy ones and 10 challenging ones, and in 3 hours you could do well in the test. All right? So I should go because I need to spend the rest of the night uploading the test. All right? So have a great night. Review. Have my voice in your mind. I hope it helps and soothes you and doesn't make you panic. There's no need to panic, okay? You have all the materials. I'm not taking anything away from you. You can use your books. I don't want you watching videos. You can use your notes, anything you've written, examples. Try and organize yourself with examples for tomorrow so that you could easily reference the problems. You can even use, if you complete all the exams and you have all the results, you can follow along to similar problems. I shouldn't be telling you that, but I'm leaving it to you to organize yourself. If you can organize yourself, it means that you know what's going on in my world. Okay? So, have a good night and have a good rest. And we'll see you, or we'll be in touch tomorrow. Okay? Bye. Oh, question about the Z table. The Z table is the only one you're going to need. You can grab it from your notes. You can also get it on the page of Moodle. It's at the top of my Moodle page. You can open up a window and use that table, or print a copy for yourself. Okay? So you have it. So yeah, Z table is the only one you're going to need for this test. Any other question? Just let me know. Keep in touch. Okay, good night.